Hello, ipXers. Today we're at the Smart Home Innovation Lab here over at NXP, and we're gonna see what they're cooking.
So first of all, to start off with, what you're going to see here today is just not a collection of smart gadgets. This is a full-scale, fully functioning home systems lab that's designed to showcase how semiconductors enable security, intelligence, and automation on the edge. Over here, we have the smart home dashboard. So the backend to this dashboard is Home Assistant, and it is a open source home automation software. So as we walk through, you will see some demos that are particularly for the lounge area, some that are related to the media room or entertainment, some that are related to kitchen safety or convenience. So you will see a variety of demos.
So this locks in that whole ecosystem into one place.
It gives you a brief overview, and it's very convenient to see what's going on in your home. You can have it on your phone, on your iPad.
And I'm assuming with this, you can add or remove functionality by incorporating other elements to that ecosystem.
Exactly. And the best part about this is that this runs on our MPU, so everything is running on the edge. It's all running locally, so you don't really need internet access. Okay. So that helps minimize some of the risks that come with a smart home lab.
It's very important to have that data secured safely. So if you can show us a little bit about how this looks like in action.
Sure. I think to begin with, we will start with some whole home automations to show you how the entire system works together. So the first one is something called as an away from home mode. So just to put this house in an away from home mode, so assume as a user you're not present in the house, you can personalize it to do different things. So we have set it so that the lights are dimmed down, the blinds are down. And then when the door opens and a user enters, it transitions into an occupied state.
I'm guessing that's that sensor on the top of the door there that's allowed you to do that. Is there any other technology that was available in that step, was utilized in that step rather?
Yeah, so there are different types of sensors available. Some are Zigbee based, some can be Matter based. So depending on how you want to integrate it within your ecosystem, you can change the different type of sensors that are available on the market. And the beauty of it is that especially if you're using Matter, you can use sensors from any company and be device agnostic, which helps with the interoperability aspect of it.
Yeah, fantastic. So what else do you have to show? Because I'm sure you've got a little bit more.
Exactly. I think our next demo should be based on Ultra-Wideband or UWB. So UWB opens up a new interaction model, which is spatial awareness within the house. So instead of asking, is someone home, it knows who is home and exactly where they are. So this allows some room level personalization for lighting, media, safety, energy, and this all happens within centimeter level of accuracy, low latency, strong security. So over here, we have NXP's UWB chips. So these are placed in 4 locations of the smart home lab. So the first one is over here. We have one in the garage area over there. We have the third one in the workbench area and the final one in the kitchen. So our use cases, assume as a user, you're listening to a podcast or listening to a song in your car, you park your car in the garage and you exit the vehicle. This experience should seamlessly follow you as you move throughout the house.
So that's quite amazing. So you could, I'm assuming, do other things with that technology as well.
Exactly. So UWB can be also used in this door lock, for example. So over here, we have our smart door lock solution. That is a reference solution that is publicly available on NXP's website. And it is now currently running on our crossover platform. So it has 5 access modalities combined. So you have your keypad, you have your fingerprint, you have your touchpad, you have the NFC, you have the UWB, and you have facial recognition with 3D depth perception. So if a registered user walks up to it, it will recognize that it's a registered user and grant you access to it. So our newer designs have transitioned to use a layer so that we can standardize and have secure digital access across all our ecosystems.
So I'm assuming that there's a lot of devices and sensors communicating with each other in order to create these different different functionality. For example, the door, the music following you, which is all quite nice, and all of that is tied into this dashboard, I'm assuming.
Exactly. So everything that we do, you can see it on the dashboard, and sometimes you can control certain things from the dashboard. So it allows you both to give a brief overview of the devices, but as well as control them too.
And you can also do that on your mobile phone, as your colleague showed me, right?
Exactly. I think we can head to the kitchen and see some cool demos over there.
So now we're here in this very abstract representation of a kitchen. Can you tell me a little bit about what we're looking at here?
Exactly. So over here we have an LLM with RAG running locally on one of our MPUs with an accelerator. So this has automatic speech recognition, large language models, text-to-speech, and a local decision making logic. So the idea is that assume you have all these user manuals for different devices and appliances that you bought and you've thrown them out and you have no idea about specific details about these appliances. So you can just ask it any question related to an appliance. So say here, for example, the smart oven, and it will give you answers. And since it's running locally on the edge, you do not need internet access. So this is especially applicable to scenarios where you have limited connectivity or where you are not able to access the internet.
This is I'm assuming, obviously, there would be an oven here. This would be incorporated into the oven, I'm assuming, correct?
Right. So the idea is you can incorporate these into specific appliances. The other idea is to use an MPU with an AI accelerator as this one as the brain, and all the demos that you have seen so far can be the nodes. So the nodes themselves can make some of the small decisions autonomously, and the brain can be consulted for larger decisions. So think about a smoke alarm being triggered. So the system can then decide whether it's because of a minor cooking mishap or if it's a larger emergency based on the brain telling you how the different systems are talking to each other.
So I'm here with Haku, and he's going to show us this demo here. So if you can tell us a little bit about what we're looking at.
Sure. This is basically a showcasing of i.MX AM series. And AM series is actually based on ARM core, Cortex A55. What we're attempting to do here is that we're implementing the soft DSP functionality. A lot of the traditional AV amps home theaters used to actually be made out of DSP dedicated IC, which actually became really bulky. So in a traditional AV receiver, like a big box that you would imagine on a home theater, would actually require 5 or 6 big boards to basically accomplish just one function, to decode, post-process, and manage the systems and everything else for the audio home theaters. But by using IAM series here, we were able to squeeze all the function into just one IC. Here you have one entire system unit instead of actually having multiple unit of boards to accomplish one home theater. So what we're able to do is to accomplish a high level of integration. So we're talking about the hardware and the software integration into just one chip. And what we're trying to do is that with that, we're not degrading any performance, but we're also basically providing the high level of entertainment and also the system stability through i.MX AM series.
Okay, so this allows you to also then make it more compact from what I'm getting from your explanation.
Correct,
Okay.
yeah. Using this actually had a couple of benefits, actually. First of all, the traditional system actually had to use multiple chips, and that was prohibitively expensive to a lot of the potential customers. So a lot of the functions like Dolby Atmos were only limited to premium premium products. But because of the high integration, we were able to lower the entry level to even mid-tier and lower-tier home theaters, even soundbars, which usually didn't carry a premium function like DTS:X or Dolby Atmos. Now we're able to actually provide that functionality into lower-tier products as well.
What is going on here? We have all these speakers around us. So what are you showcasing on that demo? You're showing that the capability of the silicon in this room here.
Dolby Atmos actually provides a immersive audio experience. So the traditional AV receiver actually had about like 11.1 or even 16 channels of lateral audio reproduction. But audio from Dolby Atmos actually enables more of an immersive, meaning that the 360 degrees of audio production capability. So we're talking about overhead speakers and lateral speakers, and all that actually is provided as a object audio rather than actually a streaming discrete channels of audio. What it means is that imagine that you actually had a traditional movie had basically just a soundtrack and the lines being spoken by all the
those would be-
actors, right? But the Dolby's attempt is to basically modernize a lot of the audio experience. So for example, if you had a helicopter flying overhead, you would actually hear the helicopter just flying as a object of audio rather than actually having to be mixed by the engineers at the
Okay.
mixing studio.
So it could, in essence, the helicopter could move completely separately from the rest of the audio.
Correct.
Through the speaker, through all the different speakers, including the overhead
Right.
speakers. And then you could do that for, I'm assuming, other things like maybe a person or
Correct.
the music or what else, trees rustling.
Yes. And some of the trailers that you may have you heard previously,
Yeah.
you heard some sound of birds
birds,
actually
yeah.
flying around. That flying bird sound is actually a discrete object sound
Okay.
that is actually going around. So that's what we're trying to actually accomplish and have people actually gain the first-hand experience.
Okay, well, thank you for sharing this demo with us today, Haku.
Of course.
We appreciate it.
Thank you so much.